Hello friends, today I will solve a LeetCode medium problem that was asked in weekly contest 402. So the problem says, we are given an integer array hours representing the time in hours. So we need to count all possible pairs I, j where I is less than j, and hours of I plus hours of j is forms a complete day. So a complete day is defined as a time duration that is exact multiple of 24 hours. So hours of I plus hours of j should be multiple of 24. So the brute force approach will be consider each possible pair I, j and check if hours of I plus hours of j is a multiple of 24 and add all such pairs that are multiple of 24 to the result. So at the end return the result. So the time complexity will be big O of n square because we are considering all possible pairs, but in the problem it's given that the length of hours array can go up to 5 into 10 to the power 5. So the brute force approach will result in TLE. So now I'll discuss the idea for the optimized solution. So for example, we have two numbers a and b and let m equal to 24. So we need to find all such pairs a and b such that a plus b is a multiple of 24. That is, k is some integer and m is 24. So now if I take mod on both sides, so this right side will become 0 and the left side will become. So as m is 24, so a mod m can go till 0 to 23. Similarly, b mod m can go from 0 to 23. So if a mod m equals to 0, so it means a is divisible by 24 So if a mod m is 0, that is a is divisible by 24, then b must be divisible by 24, so that a plus b is divisible by 24. And if a is not divisible by 24, then let's say a mod m is x, that is, so x is any value from 1 to 23, then b mod 24 must be 24 minus x. So if a mod 24 is x, then b mod 24 must be 24 minus x, so that if we add a and b, it will be divisible by 24. So now I'll consider the first example and I will solve it using the idea discussed here. So I'm maintaining a map. I'll start from the first element, that is 12. So you can see remainder will be 12 mod 24, that is 12. So now I don't see any element whose remainder is 12, because if I add that element to 12, then it will be multiple of 24. So as the map is empty here, I'll insert this remainder into the map and I'll mark its count as 1. Similarly, I'll go to next element, that is I equal to 1. Here the remainder is 12. So in the map I can see there is an entry present for 24 minus 12, that is 12. So it means an element is present before this index whose remainder is also 12. So it means if I add the current element to that element, it will be a multiple of 24. So here I'll increment the result by 1. Then I'll insert the current remainder into the remainder map. So it means these two 12, the 12 at index 0 and 12 at index 1 forms a pair. Then I'll go to next index, that is I equal to 2. Here I can see the remainder will be 6. So in the map, I need to find 24 minus 6, that is 18. So I don't see any entry for 18. So this element cannot form a pair with any of the element on its left. Then I will insert this remainder into the remainder map. Now I will go to next index, that is I equal to 3. So here the value is 24. So the remainder will be, so the remainder is 0. So now I need to check for remainder 0 in the remainder map. So I don't see any key 0 in the remainder map. So it means the current element cannot form a pair with any of the elements on its left. So I'll insert 0 to the remainder map. Then I'll go to next element, that is I equal to 5. Here the remainder will be 24 mod 24, that is 0. So I can see there is a key 0 present in the remainder map. So it means, so the current element 24 can form a pair with the 24 on its left such that the sum will be divisible by 24. So I'll increment the result by 1. So now the result will be 2, and I'll add this remainder into the remainder map. So the value for 0 will be 2 now. So now I have reached the end of the array. So the result will be 2. Similarly, let's consider the second example. So I'll start from I equal to 0. Initially result will be 0. So here remainder will be 0. So I don't see any key 0 in the remainder map. So this element cannot form a pair with any of the elements on its left. Now I'll insert the remainder into the remainder map with value 1. Next I'll go to index 1. So here remainder will be 48 mod 24, that is 0. So I can see there is a key 0 present in the remainder map. So it means the current element can form a pair with an element on its left. So we know this is the pair 48 and 72. So I'll increment the result to 1. Then I'll increment the value for key 0 to 2. Next I'll go to next index, that is I equal to 2. Here you can see the remainder is 24 mod 24, that is 0. So in the remainder map, value for key 0 is 2. It means there are two elements on its left whose remainder is 0. So if I add those two elements with the current element, the sum will be divisible by 24. So now we can form two pairs, that is 72, 24 and 48, 24. So I'll increment the result by 2, that is the value of the key 0. So now the updated result will be 3. At the end, I'll increment the value for key 0 to 3. Next, I'll go to next index, that is I equal to 3. So here remainder will be 3. So I'm in the second case. Now I'll check for 24 minus 3, that is 21 in the remainder map. So I don't see any entry for 21. So it means the current element cannot form a pair with any of the previous element such that the sum will be divisible by 24. So now I'll stop here because I have reached the end of the array. So the result will be 3. So now I'll code the solution. So instead of using a map, we know that the remainder can go from 0 to 23. So I'll declare a frequency array. Now I'm declaring a result variable. So now I'll run a for loop for each hour in the hours array. First, I'll compute the remainder. Then I'll update the result. So if remainder equal to 0, then I'll add the frequency of 0 to the result. Else I'll add the frequency of 24 minus remainder to the result. Then I'll increment the frequency of remainder. At the end, I'll return the result. So let's run it for the sample test cases. So the sample test cases are running fine. Now I'll submit it. So you can see it's working as expected. So first I'm declaring a frequency array of size 24. Then for each hour in the hours array, first I'm computing the remainder. So if the remainder is 0, that means the current element is divisible by 24. So I'll try to look for elements on its left which are divisible by 24. So the frequency of 0 will give me the count of elements that are on its left and are divisible by 24. Else, if the current remainder is not equal to 0, then I'll look for elements on its left whose remainder is 24 minus the current remainder, and that count will be given by the frequency of 24 minus remainder. So if I add those two elements, the sum will be divisible by 24, and I am adding those frequency to the result variable. Then I am incrementing the frequency of remainder. At the end, I am returning the result. So the time complexity will be big O of n because we are traversing the input array only once, and for each element we are doing some constant number of operations. And as I am using an auxiliary array of size 24 which is constant, the space complexity will be big O of 1. Thank you.